Welcome and thank you for taking time out of your busy day to join us today. My name is Phil Locke and I'm the plumbing team leader in the VBA's technical and regulation team. I'd like to begin by acknowledging the traditional owners of the land in which we are gathered, pay our respects to their elders, past, present. We recognise the value, the ongoing contribution of the Aboriginal people and communities to Victorian life. As Victoria's building and plumbing regulator, we safeguard Victoria's future livability. Our role is not to set policy, but to support industry to understand and comply. We have a role in ensuring practitioners understand how to do things correctly and in discouraging risky, harmful, or illegal behaviour within the building and plumbing industries. Today's Practitioner Education Series webinar, Common Roof Drainage Inquiries and Faults, Box Gutters, will be presented by Senior Technical Advisor in the plumbing team, Neville Campbell. Neville has over 17 years experience in the plumbing industry, and Neville has worked in both commercial and domestic sectors prior to joining the VBA. Neville is an apt technical writer and routinely represents the VBA in matters before the Civil Administration Tribunal. VBA's Practitioner Education Series helps support the building and plumbing industries and providing practical insight, evidence-based strategies and useful resources to practitioners. The webinar series aims to give practitioners an improved and consistent understanding of their regulatory requirements and to help safeguard Victoria's future. Today's sessions are recorded and will be made available in the coming days on the VBA website, and we will be conducting live polls which will appear automatically on your screen. And questions can be submitted and voted on by the Q&A function. So without further ado, I'll throw over to Neville for his presentation. Thanks, Neville.
Thanks, Phil. Welcome everyone to today's session. The purpose of this webinar is to highlight the most common inquiries and faults relating to box gutter systems that are not being designed in a deemed to satisfy manner. The learning goal for this session is to identify the fundamental requirements for the design and installation of box gutter systems using deemed to satisfy methods. The learning objectives for this session are for participants to understand the fundamental deemed to satisfy installation requirements for box gutters discharging to a rainhead, box gutters discharging to a sump with a side overflow, and box gutters discharging to a sump with a high capacity overflow. By the end of this session, participants should be able to identify parameters for rainheads and sumps, identify appropriate overflow size and location, and identify correct downpipe sizing and outlet location. So what will we cover? We'll look at box gutters discharging to a rainhead, start with grade and design flow, rainhead sizing, overflow, downpipe sizing and outlet location. Then we'll look at the same for sumps discharging from the side overflow, grade, design flow, sump sizing, overflow, downpipe location. Then we'll move into box gutters discharging to a sump with a high capacity overflow. This is one that's particularly poorly understood, which we do see some issues with. We'll look at grade and design flow, sump sizing, overflow, downpipe sizing and outlet location. Then we'll look at box gutters general as our final topic. So we'll look at gradient, sole width, changes of direction, discharge to sumps and rainheads, overflow designs, sealing of sumps and rainheads, expansion provision, support. We'll look at what a box gutter is for the purpose of sizing, and we'll look at some conflict between standards. Then we'll have some time at the end for Q&A. Box gutter compliance pathways in the National Construction Code, or NCC. Excuse me. In Victoria, the design of box gutters must demonstrate compliance with all the relevant performance requirements of the National Construction Code, or demonstrate that the solution used is at least equivalent to the deemed to satisfy provisions. When we're talking about deemed to satisfy provisions for box gutter sizing and design, excuse me, we're talking about the standards which sit here. So you've got two pathways. You have performance solution or deemed to satisfy solution. These are your two options for compliance. The VMIA have produced a three-part webinar series on developing plumbing performance solutions, which can be found using the QR code at the bottom here. They are from early last year and December the year before. So if you are looking for those, you may need to scroll down the page just a little bit. In Victoria, provisions of the National Construction Code require building and plumbing practitioners to comply with the AS NZS 3500 Part 3 for the deemed to satisfy design of box gutter systems. Alternatively, a performance solution may be developed to demonstrate compliance. The latest version of the standard was published on the 28th of May 2021. The VBA has applied a transition period until the 1st of May 2023 before it requires the revised standards to be applied in practice. So that will coincide with the adoption of the 2022 version of the National Construction Code. From the 1st of May 2023, Victorian variation to Volume 3 of the NCC, Plumbing Code of Australia, will adopt the HB 39 under the Plumbing Code and give precedence to the 3500 Part 3 in circumstances where there is any inconsistency between these two documents. You can learn more about the transition period and Victoria's variations through these QR codes to the side. The box gutter designs in the following presentation are typical of designs that are prescribed by the general methods of the AS NZS 3500 Part 3 2021. And as such, these designs are deemed to satisfy the performance requirements of the Plumbing Code of Australia. Where gutter designs that are inconsistent with DTS methods are intended to be installed, a performance solution must be developed prior to construction commencing. If you're not familiar with what a performance solution is, I highly recommend you use that QR code on the previous slide. The AS NZS 3500 Part 3 2021 was prepared by the Joint Standards Australia Standards New Zealand Committee, WS014 Plumbing and Drainage, to supersede 3500 2018 version. 3500 Part 3 2018 version. A full list of the WS14 committee members is published in front of the book, and it should be noted that the Australian Building Codes Board represent the VBA on this committee by proxy. The following presentation will outline many of the requirements for deemed to satisfy design of box gutter systems in accordance with the AS NZS 3500 Part 3 2021. Anyone who has concerns or special interests can submit excuse me, proposal for change to the standard via this QR code. Box gutters discharging to a rainhead. What does a deemed to satisfy installation look like? Deemed to satisfy grade and design flow. Box gutter width, grade and flow are required to chart the minimum depth of a box gutter that discharges to a rainhead. The design flow rate can be plotted between 3 and 16 litres per second. Sole widths of 200 millimetres cannot accommodate flow rates exceeding 10.5 litres per second. Larger buildings may also require internal sumps to prevent box gutters flows exceeding 16 litres per second. Grades of box gutters can be charted at 1 in 200, 1 in 150, 1 in 100 and 1 in 40. Deemed to satisfy rainhead sizing. Minimum depth and length of a rainhead are dependent on the flow rate, the size and shape of the downpipe selected, round, square or rectangle, the box gutter sole width. The width of the rainhead must be at least equal to the width of the box gutter. So it can be wider, but it must be at least equal to the width of the box gutter. Deemed to satisfy rainhead overflow. The rear of the rainhead overflow must be at least 25 millimetres below the sole of the box gutter. The width of the overflow is equal to the width of the rainhead. The rainhead must be left open above the overflow weir. Ned Kelly slots, round holes, vertical chutes or ducts are not deemed to satisfy designs. So you can see here, sole of our gutter, see the rear of our overflow here. It's 25 mil gap between them. So the overflow height equals HR, which is the height of a rainhead, minus 25 millimetres. Notice over here that it's open, completely open above the rear of the rainhead. Deemed to satisfy downpipe sizing and outlet location. Size and shape of the downpipe is selected when sizing the downpipe. Round downpipes must be fitted so that the centre of the downpipe is not closer than the diameter of the downpipe to the nearest vertical side of the rainhead. Square or rectangle downpipes must be fitted so that the centre of the downpipe is not closer than the average of the two side dimensions of the downpipe from the nearest vertical side of the rainhead. Downpipes must discharge vertically from the sole of the rainhead. Okay, question time. So choose the one correct answer that relates to deemed to satisfy designs of rainhead overflows. Is it number one, the width of the overflow is equal to the width of the rainhead? 2, the rainhead must be left open above the overflow weir. 3, Ned Kelly slots, round holes, vertical chutes are not deemed to satisfy designs. Or 4, all of the above. Any participants joining in here? So here we go. We can get some participants. All the above. Well done. Overwhelmingly. Moving on. Box gutters discharging to a sump with side overflow. So what does it deem to satisfy installation look like? Deemed to satisfy grade and design flow. Just like our box gutter discharging to a rainhead, flow rate of each box gutter is required to chart the minimum depth of the gutter. The design flow rate can be charted between 3 and 16 litres per second. Sole widths of 200 millimetres cannot accommodate flow rates in excess of 10.5 litres per second. And grades for box gutters can be charted at 1 in 200, 1 in 150, 1 in 100, and 1 in 40. Deemed to satisfy sump size. Depth of the sump is dependent on the downpipe options available for the design flow rate. The minimum length of the sump is equal to the sum of the width of the overflow channel 2 times the clearance from the side of the sump. These are known as the lock and the lock. Under no circumstances should the sump length be less than 400 millimetres. So if we're looking here, this width of the overflow channel can be, which we will touch on in a few slides, is selected from the standard. This, what's known as the lock, which is in this case is the clearance from each side of the sump, is selected from also from a chart in the standard. So these are not arbitrary numbers; they actually are relative to each other. We'll look at that as we move along. The width of the sump must be equal to the width of the box gutter. It is permitted to put a 25 mm lap around the sump. So just for clarity's sake, the length of the sump is this way, the width of the sump is this way. deemed to satisfy overflow. There are three available options for the width of an overflow channel. These are 200, 300 and 450 millimetres. If wider slots than necessary are used, the sizing should be based on the lower DTS width and the length of the sump adjusted to accommodate the lock. So if you wanted to use, for example, the range that is available to be plotted from the standard is for the width of this overflow channel is 200, 300 or 450. If you wanted to use, for example, a 200 or 275 millimetre slot, you could. That would be oversized. This is, of course, a minimum standard. However, you still need to accommodate the lock on either side, which is also charted from the standard. So that would affect the sump length. Depth of the overflow channel is dependent on the width chosen and the corresponding design flow for the box gutter. Now we're looking at this here, and the design flow downflow. That's what gives us the depth of the overflow channel. Vertical position of the overflow, known as the HT, is the minimum height from the top of the gutter to the bottom of the overflow. So it's this height here, top of the gutter, bottom of the overflow. It's calculated using the formula ROC, which is this, DOC, which is the depth of our overflow channel, and HF, which, as we all know, is our freeboard, minus 0.7 this lock, which is charted from the standard. 0.7 is the minimum height that the overflow channel will be off the sole of the box gutter at the sump. So that formula gives us this height from the top of the gutter. Standard does permit the overflow to be moved a little, but we do run into problems if it's moved outside of the sump, obviously because the gutters are on grade, and this minimum height above the sole of the overflow channel then becomes affected when we start to move it along. Round holes, vertical chutes or ducts are not deemed to satisfy designs. I think that's one that's poorly understood. Really, there's another arbitrary numbers. They are actually calculated from the standard. So when you start applying things like round holes, etc., there is nothing to base that sizing on. It's where you're into performance solution territory. Downpipe sizing and outlet location. The available downpipe sizes are dependent on the design flow rate of the box gutter and the corresponding sump depth. Round downpipes must be fitted so that the centre of the downpipe is not closer than the diameter of the downpipe from the nearest vertical side of the sump. So this is exactly the same as our rainheads. Square or rectangle downpipes must be fitted so that the centre of the downpipe is not closer than the average of the two side dimensions of the downpipe from the nearest vertical side of the sump. Downpipes must discharge vertically from the sole of the sump. They come out the bottom. We do see them from time to time coming out the side and out the back. Question time again. Okay, choose the one correct answer that applies to the deemed to satisfy design of sumps and overflows. Is it 1, the overflow can be any width or height? 2, the length of the sump depends on the width of the overflow channel, 2 times the lock. 3, the value of lock is plotted from the standard. Or 4, both 2 and 3. Where did we go? 83% correct. Excellent. Okay, box gutters discharging to a sump with a high capacity overflow. So what does a deemed to satisfy installation look like? Deemed to satisfy design and grade, design flow. The flow rate of each box gutter is required to be plotted. Is required to plot the minimum depth of the gutter from the standard ASNZS 3500 R3. Where one gutter receives more catchment than others, the sizing must be placed on the largest gutter. Design flow rate can be plotted between 3 and 16 litres per second, and sole widths of 200 millimetres cannot accommodate flow rates exceeding 10.5 litres per second. Grades for box gutters can be plotted at 1 in 200, 1 in 150, 1 in 100, 1 in 40. Deemed to satisfy sump depth. The depth of the sump with a high capacity overflow is dependent on the plotted overflow weir height, known as the lock, the datum level from where the sump depth is measured. So this is our sump depth here. There is, of course, also a datum zone. And that datum zone, which we'll look at next, be anywhere in this in here from the sole to 60 mil below. Datum level is equal to the sole. Datum level is equal to the sole of the box gutter. Value of lock is greater than 60 millimetres, or below the sole of the gutter. Value of lock is less than 60 millimetres. That will depend on the plotted size of the lock. Notice with high capacities, it's different to some side overflows. With some side overflows, the lock is actually a distance from the edge of the sump to the overflow. With the high capacities, the lock is actually the distance between the sole of the gutter at the sump and the overflow weir height. So it's this distance here. Under no circumstances should a sump with a high capacity overflow be shallower than 150 millimetres from the datum point. So again, it's going to depend on what your datum point was. Then you add your 150 millimetres. So in practice, this actual distance from the sole of the gutter to the bottom of the sump may be deeper than 150. Deemed to satisfy sump length. Primary sumps incorporating a high capacity overflow must be 600 millimetres in length. This includes a 200 millimetre secondary sump and a 200 millimetre space either side of the secondary sump. So this is our primary sump. We're looking at here, this is the length of the sump. Sump length equals 600 mil. This is our secondary sump, which is our overflow device. It's 200 millimetres wide. You'll notice there's a 200 millimetre space either side. Gives us a total length of 600 millimetres. The width of the primary sump is the same as the box gutter. So just to reiterate, this is the width and this is the length. That's right. Deemed to satisfy overflow for a secondary sump. Standard requires the upstream sole of the secondary sump to be 40 millimetres, and the downstream sole to be 60 millimetres. 40 millimetres here, 60 millimetres here. The weir must be the full width of the primary sump. Here on the side. The height of the weir above the gutter sole must be plotted from the standard as required by the general method. So that's known as the lock. It's this height here. It's the height of the overflow weir above the gutter sole that is plotted from the standards. Height of the sump, the rest of it, from the bottom of the sump to the sole of the gutter, will depend on the size of the sump. outlet, the overflow outlet must have an equal or greater design flow from the downpipe. Inverted pops and other designs used as high capacity overflows are not deemed to satisfy designs. They may work, and they may be justified through a form solution perhaps, but they are not deemed to satisfy design. Deemed to satisfy downpipe sizing and outlet location. Downpipe must be sized for the total design flow through the outlet. Downpipe and overflow must discharge vertically from the sole of the sump. Overflow outlet must be positioned on the centre line inside the secondary sump. You can see here, this is our overflow outlet. This is our overflow sump. This is the top of the overflow sump. Obviously, if we're looking down on it like this in plan view, the view obstructs the downpipe because it would be covered by the sole of the secondary sump. Downpipe outlet may be moved longitudinally to allow maintenance access, but must not cross the centre line of the sump. So it can be moved out this way, no problem, all the other way, but it can't be moved across that centre line. Downpipe centre must not be closer to the edge of the sump than the diameter of the outlet. That's for round, or if it were square, on average of the two sides. So that's this distance here. Centre of the outlet to the edge of the sump, or this way. Shouldn't be closer than the diameter at the diameter of the round, or the average of the two sides of the square or rectangle. Okay, question time. Choose the correct answer that applies to the deemed to satisfy design of sumps with a high capacity overflow. 1, the overflow can be an inverted pot. 2, the overflow just needs to be higher than the sump. 3, there is only one deemed to satisfy design for a sump with high capacity overflow. Give that a minute for people to answer. Excellent. 90%. 90% correct. Excellent. Yes, unfortunately, that question probably is a little misleading in that it's only one deemed to satisfy design. The designs will, of course, vary depending on the depth of the sump and the width of the box gutter. But the rest of it, the length of it, the overflow, like all that stuff, it's still a requirement of the standards. It's plotted that way for a deemed to satisfy design. General requirements for all types of box gutters. To be considered a deemed to satisfy solution, box gutters must have a uniform longitudinal slope towards the outlet. So that's a uniform slope, must be consistent from start to finish. Box gutter grades can be plotted from the standard at 1 in 200, 1 in 150, 1 in 800, 1 in 40. To be considered a DTS solution or deemed to satisfy solution, box gutter sole widths can be plotted from the standard 200, 300, 375, 450, 425, and 600 millimetres. Sizes between the minimum and maximum can be used if they are sized to the lower DTS. Gutters passing through a parapet must not reduce below the minimum design width and depth of the gutter. sole of the gutter can taper towards the outlet if there is a proportional increase in depth and sole width of the gutter is not reduced below the minimum design width. So in practice, what that means is if we're passing box gutter through this parapet and the design we had worked out the design width of the gutter would be 200 millimetres. It shouldn't be less than that passing through the parapet. So if you wanted to use a tapered gutter, you could, by all means, you could start at 300 mil or wider, taper it down to 200, which was the sole width you're basing the sizing on, but you would need to have a proportional increase in depth as you pass through. Changes of direction. So to be considered a DTS solution, box gutters must be straight. Must be straight and not change direction. This one's pretty straightforward. I think you can see the dog leg in this one, chicaning in this one. See just a dog leg in this one here. Obviously not straight. To be considered a DTS solution, box gutters must discharge to a sump or a rainhead at the downstream end without changing direction. So side chutes, three-sided sumps and pops in the sole of box gutter are non-DTS designs. So they may possibly be demonstrated that they work through a perform solution, but they're not a satisfied design. The standards are quite clear. The box gutter must discharge at the downstream end and be straight. You can see this one here, we've got a side chute. Here we've got a pop in the bottom of the gutter. Here we've got a three-sided sump that discharges to a rainhead. Inverted pops, Ned Kelly slots, round holes are not deemed to satisfy designs. This doesn't mean that their compliance can't be demonstrated by a performance solution. It's possible that it can. It would depend on the paperwork and the testing or whatever verification methods you've used to justify it. Overflow devices must discharge to atmosphere and be clear of neighbouring properties and public areas. That's on us. But other considerations, you should really think about the features of the building. You don't want to discharge them over a doorway or over a window or something like that, where they're really going to be nuisance, or where they're going to damage the property. Sealing of sumps and rainheads. So sumps and rainheads, to be considered a DTS solution, they must be fit and fully sealed to the box gutter. Fairly straightforward, that one, but unfortunately it is passed over a lot. To be considered a DTS solution, box gutter support systems must have provision for expansion, with a distance between fixed points exceeds 6 metres and at appropriate intervals for the material and the situation as prescribed by the standard. You can see with this one, fixed point here, we've got we have a rainhead. It's a fixed point because it's fully sealed to the box gutter. It's free to move it the other way. With longer gutters, perhaps we might have a rainhead at each end and internal sumps. So we've got fixed points here, or even sumps, sump to sump, we might have a fixed point. So where these exceed 6 metres, must have expansion in accordance with the standard if they are to be considered to satisfy. To be considered a DTS solution, box gutter support systems must be able to support the weight of the gutter and sumps when full of water, as well as the trafficable load at any point in the gutters and sumps. They must be supported by a compatible material or be shielded from incompatible material, incompatible support material with a non-abrasive, impervious and non-conducting material. The sides of the box gutters must have enough structural strength so that the water pressure cannot cause deformation. Look at this one here. You can see the bottom of the end of this box gutter is completely unsupported. Like my size, 110 kilos, I go straight through that. The other issues or common issues that we see is quite often we might see particle board flooring used to support the support the box gutter. Some particle board floorings contain formaldehyde. Formaldehyde reacts with metal. That's what's quite corrosive. That's where our shielding. In addition to that, other things that we do see commonly is particle board flooring and trimmers used to support the box gutter. So they might run trimmers down the side and then nail particle board flooring up from underneath. Particle board flooring, of course, in that scenario isn't actually supported, so it's not actually being used the way it should as a support mechanism. It's actually just being suspended by the runners. For the purpose of sizing box gutters and sumps and rainheads, a box gutter is all the box gutter that discharges to a sump or a rainhead. For a rainhead, this might be a straight length, or is a straight length, and for a sump, the discharge could come from two opposing sides. Sumps with high capacity overflows positioned in a corner and receiving discharge from box gutters at 90 degrees are beyond the scope of the standard. So here we have a box gutter discharging to a downpipe, and again here a box gutter and another box gutter. Sumps in a corner. If you've got a high capacity there, you need to have those. It's outside the scope of the standard. If you don't have your wheels of your rainhead set up the way that we've described previously. Of course, there's nothing wrong with having a box gutter, a sump in a corner, and perhaps having one gutter fall to it, one away from it. Conflict between standards. Primary standard for the deemed to satisfy box gutter design is AS/NZS 3500 Part 3. The SAHB 39 is also a primary standard. It's actually a handbook, a primary reference document, and provides the installation requirements for box gutters. In some circumstances, information contained in HB 39 is inconsistent with the requirements set out in 3500 Part 3. In these situations, the requirements of 3500 Part 3 are the requirements that should be applied. An example of conflict between standards is box gutter minimum depth. HB 39 says that for commercial or industrial installations, box gutters can have a minimum size of 300mm sole and 75mm deep at the high end. It also says that for a minimum size for domestic installation, it would be 200mm wide and 75mm high, 75mm deep at the high end. And that, of course, is commensurate to the roof catchment area served by the gutter. Now, these dimensions are beyond the scope of the standard, as they cannot be plotted from sizing graphs of AS/NZS 3500 Part 3, and I'll show you why as we move through the slides. So here we have a table that shows the minimum depth for a minimum flow rate. So this is the absolute minimum for a box gutter size. So if we look here, we can see 200mm width of the box gutter, 200mm at the minimum flow rate, which can be plotted from the standard, which is 3 litres per second. You would never size in a DTS manner to anything less than 3 litres per second. At a maximum slope, we're looking at 93mm deep. For a 300mm wide gutter, even at a maximum slope, again, 3 litres per second, we're still looking at 85mm deep. So neither of those could ever actually be plotted at 75mm. For a box gutter to be 75mm deep at a minimum flow rate, 3 litres per second, we're looking at a 600mm gutter at grade of 1 in 40. So it's actually quite a difference. Now, I know there will be people who say that's not correct, but my numbers here don't work out. Just pay attention to this down here. When you're using standards to chart the depth, there are slight variations due to parallax error, the position of your way, the thickness of the axis line, the ruler you use. If you're within a few millimetres either side, I would say you're probably on par with the requirements. Looking at the other end, this table is for the minimum depth of the guts of a box of gutter for a maximum flow rate. So we're looking at minimum depths of box gutters 16 litres per second. So you'll note here, first thing you'll notice is for a 200mm gutter, it's not an option at any grade at all, at 16 litres per second. The reason for that is that the axis line for a 200mm gutter peaks at 10.5 litres per second, which you would have heard me repeat a few times throughout this presentation. Excuse me. These tables are a minimum standard. Excuse me. These standards are a minimum standard. That doesn't mean you can't use that. Apologies. Something. It doesn't mean you can't use a wider gutter. So, for example, if you're going to use a 350mm gutter, you would base your sizing on the 300mm. Conflict within a single standard. This is an example of conflict within a single standard. The ASNZS 3500 Part 3 says that a 100 by 50mm rectangle downpipe may be used for the connection of a sump or rainhead. Downpipes of this dimension are not an available option that can be plotted from the sizing graphs of 3500 Part 3. Question time. Choose the correct answer that applies to the minimum depth. That applies to the minimum deemed to satisfy depths of a box gutter. 1, a box gutter can be 200 by 75mm for domestic and 300 by 75 for commercial. 2, the minimum depth must be plotted from the design graphs in the standard using design flow sole width grade. How did we go? Excellent, 91%. Minimum depth must be plotted from the standard. Moving on. Okay, that brings us to our conclusion. We've looked at deemed to satisfy design parameters for rainheads and sumps, rainhead and sump sizing, overflow size and location, and downpipe sizing and outlet location. Participants should now be able to identify sizing parameters for rainheads and sumps, identify appropriate overflow size and location, and identify correct downpipe sizing and location. If you're a licensed plumber, you should be aware of the stuff we've discussed. If you're in designer perhaps or something like that, you should now be aware of the correlation between these measurements. They're not understanding that they're not arbitrary numbers. One thing does affect the next. Question and answer time. Let's take a look at what we've collected. Sorry, just okay, to the team.
I'll ask the first question, Neville, and just let you get your bearings for a moment. So,
Yeah.
Our first question is, why is it that sufficient size overflows are not deemed okay in rainheads, and we need to put this new style rainhead in? And Warren, you flagged that one to answer.
Yeah, no, I'm happy to go on with that. Since the removal of we'll call it the Ned Kelly slotted rainhead from HB 39, we're not saying that anything, as we've already discussed, deemed to satisfy performance solutions are two pathways and options. So there are things like inverted pops that were mentioned in the presentation. We're not saying they won't function or they will function. It's just there's two different pathways. But getting back to the Ned Kelly slotted rainhead, because the slotted rainhead was removed in HB 39, which was a reference document, the only, if we then refer back to Part 3, and Part 3, this is a sizing document. So HB 114 and HB 39 mentions Part 3 as a sizing document. And Appendix I, I'll go in the 2018 ones at the moment, I'll mention because the appendixes have changed. But in that, the Appendix I is actually a normative section. So when you read your standards, you should actually be looking at the preface and the start and working out what's normative and informative. And I suppose you could say fortunate or unfortunate, depending on what your viewpoint is on this. The open-fronted rainhead, by the standard and how you interpret the standard as a normative section, is left us with that scenario of the open-fronted rainhead. And I get the comments about they're unsightly and everything else. It doesn't mean that you can't put Ned Kelly slotted rainheads in. There was even comments about side chutes and sizing, providing it's all adequately sized, but however, you'd have to still flag it as a performance solution. Hopefully I've answered that to everyone.
I'll just jump in for a second there. Comms, apologies, I can't actually see what's been flagged or answered. So I may need you to MC this, please.
No worries. We'll move to the second question. So can you please outline what steps plumbers actually need to take in order to prove any installation is deemed to satisfy, and what evidence they should have to show that? I think that's another one, Warren, you flagged, if anyone else would chime in.
Yeah, no, well, look, getting, I suppose, let's get back to practical first. First of all, whatever system you put in should be functioning. I mean, and it's quite clear, for example, in the NCC, or even if you through the standard, that say a performance requirement like an overflow or to be watertight is a mandatory requirement, regardless of which pathway you follow. It's mandatory. Now, if you're going down the performance solution road, you should be really supporting that via calculations or testing or some sort of information. I sort of hang my hat on calculations. Now, if a plumber is not 100% certain on that, they possibly should seek additional advice on that. But calculations is probably the best way to go.
Thank you. We've got a couple of other questions now. Do plumbers need to consider warranty of materials used when certifying plumbing work they have carried out? For example, where a manufacturer will not provide warranty for galvanised roof sheets due to white rust, and the plumber is requested to install galvanised roof sheets.
I might answer that one. Just in relation, plumbing certification does not normally cover warranty of a product. The installation and the certification warranty is in relation to the plumber's installation warranty, but not on the product warranty. But it's an interesting question that I've answered that question as a response through the Q&A, but I will take that up individually. I'll speak to the roll formers because that's an issue that I was not aware of. This is about the use of galvanised iron product where the manufacturer or roll form is not providing a warranty on that product. So I think we need to take some advice on that.
Thank you. Another question we have is, are nylon anchors approved for fixing flashings to parapet and building masonry walls?
Again, I've already typed an answer to that to the caller, the question and answer. HB 39 does not specify the fixing product. It just says that the product has to be fit for its intended purpose and compatible with the material that's being fixed.
Thank you. We have a number of other questions in the Q&A box. Our team will work after the webinar to provide some written answers to those and share them with you all with our proof of attendance certificate in a couple of weeks' time. So thank you all for your questions.
Thank you for joining us today. We hope you've enjoyed the session. If we didn't manage to answer your questions, we will endeavour to do so in the coming weeks. We will be sending an email in the coming weeks that includes a webinar survey, as well as proof of attendance, Q&A sheet, and a link to today's webinar video and slideshow. To find out when the next Practitioner Education Series webinar will be held, please visit the VBA website in the coming days and keep an eye out for our emails. Thanks everyone for your time.